Hello, fellow Minecrafters. Um, I'm here to show you the electrical age mod because there are not many videos around on YouTube and a lot of people do not know how to begin with it. The developers are French, which makes it extra difficult for them to explain everything in English. Before we can start with the mod, um, I will tell a little bit about the um, basic rules of electricity. Now I only have 10 minutes um, because I'm using a free version of Bandicam on my crappy laptop. Anyhow, the first thing with electricity is that we have a few um, things that you need to know, of course. The first thing is voltage, which is the strength that makes the current flow, which we use the capital U for in a formula. Then we have current, which is the electrical flow itself, measured in ampere, capital I in formulas. Then we have power, which is an energy flow, not to be mistaken with the electrical flow. The energy flow is measured in watt, or capital P in formulas. Next is resistance, which is the difficulty for electricity to take apart, measured in ohms, or the omega symbol. In formulas, the capital R. Next is energy, which is an amount of work measured in joule, um, capital E in a formula. The formula we have is power is voltage multiplied by current. If we want to figure out any of the other two variables, we just put our hand above the one we want to know, in this case current, and we get the P for power divided by voltage is the current. Same goes for the voltage is power divided by current. Righto. Next formula is voltage divided by resistance times current. Same goes here. Put your hand above the thing you want to know and you get the formula. Okay, so we have an ohm meter which we need to probe the cables and the devices. We need a ground cable with a resistance of 12.5 milliohms. We need to have a low voltage cable which can handle 50 volts at 20 amps, 1000 watts, and has a resistance of 25 milliohms. Now there are more different types of cables which can handle more stress. Do not over stress the cable because it will explode because the temperature will rise. You can check the temperature of a cable with the ohm meter. Next is a signal cable which we will need to read values from the cable if we use a probe. Next is the solar panel which uses or produces 14.8 volts, produces 65 watts, and if we use the formula, please press pause if you want to read it, we get 4.39 amps. Right, next one, we need a flat lamp socket with a cable and a light bulb. We need a low voltage switch, and I'll get to this later. We need, of course, a battery. It can it runs on 50 volts. It produces 250 watts. It stores 60 kilojoules fully charged, and it has a resistance of 40 milliohms. Okay, there we have the finished setup. You can check it from the sky. That is what we are going to make in 5 minutes. So we have the ground cable. We have a solar panel, wrong side up. Okay, so the blue side is the negative side, which we will hook up to our ground cable. The red side is the positive side, but I'm going to hook up 1, 2, 3 extra solar panels, which make 4, because earlier we said that one solar panel is 14.8 volts, times 4 is a little over 50 volts. We're going to hook up the cable, check it with the voltmeter, and it has 59 volts. Next, we are going to extend the cable a bit longer and attach the cost-oriented battery. Simply, wrong side, that's the positive side. Simply because it's cost-oriented, it's cheap. Now, it won't last as long as other batteries, but that's not a problem. Of course, this side we're going to hook up a ground cable directly to the battery. Now, you can see with the voltmeter that we have current going through the cable, 249 watts. That is because the sun is directly above the panels. Now we have 4 times the 65 watts, which is 260 volts. So it can produce 260. We're almost at maximum capacity of what it can produce. Now we can see here that the battery is currently being charged. We have an overvoltage protection slot and overheating protection slot. We're not going to use it. We are splitting the cable, okay, and hooking up 1, 2, 3, 4 lights. Click the lights, powered by cable, shift with a 50 volt economic light bulb and a low voltage cable. Okay, say here, yes, say here. Please pause it if you're not really sure what I'm doing and rewind it. Now, as we can see on the cable, the lights are using 68 watts, 1.28 amps, and we can see that it still produces electricity more than it's consuming, so the battery should be charging, which is correct. Now, if we change to, let's say, nighttime, no, not anymore. Yes, almost nighttime. It's almost not producing nothing anymore. Okay. Yeah. We can see that the battery is already depleting. It's discharging within 17 minutes, 16. It's going fairly fast. This is the amount of power that is going out of the battery. This is the amount of energy left, and this is the life of the battery. Now, we can see the battery is slowly dying. Once it's at 0%, it's dead. We really need to replace it. Now, I can hook up, rotate it with C, the wrench key, hook up to a light switch, and turn it on. We can see that it is consuming power. If we turn off the switch, we can see that it's not consuming any power. Very well, turn it on. That's it. In my next video, I will be showing how to use the data logger and use a monitor to monitor what is going through the cables. Thank you for watching, and I will see you.